Welcome to part 5. In this part, you'll solve grade 12 geometric problems from past exam papers. We're going to follow the same method that we have used in part 3 of eliminating theorems which are not in a problem. Now, let's look at one question that we have, an exam question that we have. In this diagram here, we are told that BC is equals to CD. Now, we are told to prove that triangle AEB is similar to triangle ADC. Now, we look, triangle AEB, which is this triangle here. We need to prove that this triangle is similar to triangle ADC. So we're proving that this triangle is similar to this triangle there. Now, the first thing that I think of is equiangular triangles. I can solve showing that the two triangles are equiangular. And by equiangular, we know that the corresponding angles are equal. Now, let's prove that triangle AEB is similar to triangle ADC. And we must go back to our theorems where we can see that theorem number 1 is not there where there's no center. If there's no center, it means theorem number 1 and theorem number 2 are not there. Theorem number 3 is not there. We can assume that this is a diameter. We are only told that BC is equals to CD in this diagram. That's the only thing that we are told. That's the only story that have been told to us. Therefore, we can't assume that this is a diameter. We can't assume that this is a diameter. Therefore, theorem number 3 is not there as well. But you can see there and there, theorem number 4 is there. You can see again there and there, theorem number 4 is there. So theorem number 4, I can take it that it is there. Now theorem number 5, this is a cyclic quad. Yes, we might use all the theorems in this problem, or we might not use the theorems. Yes, we were never told that this is a cyclic quad. Therefore, I cannot assume that this is a cyclic quad. And we were never told that A, B, C, D are points on the circumference. Therefore, we cannot assume that this is a cyclic quad. Therefore, theorem number 5 and theorem number 6 are out. There's no tangents. So theorem number 7, 8, 9 are out. So we only have theorem number 4 in this problem here. Now, let's prove that triangle AEB is similar to triangle ADC. So this triangle, we want to prove that it is similar to this triangle. Now, for us to do that, we start. In triangle AEB and triangle ADC, angle A1 is equals to angle A2. Why is that? It is because that these angles are subtended by equal length. This angle is opposite this length. This angle is also opposite that length. Therefore, it means that this angle is equal to that angle since they are subtended, since they are opposite equal lengths. Therefore, angle A1 is equal to angle A2. Reason why we're saying these two are equal: angles opposite or angles subtended or subtended by equal length. Angles opposite equal lengths. Now, we know that this angle in this triangle is equals to this angle there. Angle B2 is equals to angle C1, because angle C1, it's in this triangle which we are proving that it is similar. Therefore, this angle, it's in this triangle. Angle C1, it's in this triangle. Therefore, angle B2 is equals to angle C1. We've just said it, that we've got theorem number 4 from grade 11, which is part 2. Then we know that angles at the same segment. Angles at the same segment are equal, we know. Now, obviously now, since this angle is equals to this angle, and this angle here is equals to this angle there, it means that this angle here is going to be equals to this whole angle there. Therefore, angle E2 is equals to, obviously, C angle DA is equals to C angle DA. Reason, third angle of a triangle. Third angle of a triangle. Therefore, triangle AEB is similar to triangle ADC. Reason, obviously, equiangular triangles, or angle, angle, angle. Equiangular triangles, or angle, 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 if we wanted. Now, B, they say to us we must prove that AE over AC, you can see that AE over AC is equals to AB over AD. So you can see that AE is a side on this triangle. AC, we can see that it's a side on this triangle. We can see that AB is a side on this triangle. We can see that AD is a side on this triangle. And we've just proved that this triangle is similar to this triangle. Therefore, it should be easy for us to prove that. How do we do that? We need, obviously, to highlight the angles which are equal. And this angle here is equals to this angle there. I'm highlighting with using different colors. Also, I can highlight this angle there, which is equals to this angle there in this triangle. We can also highlight using a different color, where I'm going to have this angle there, which we have just said it, that it is equals to this angle there. Therefore, it is going to be easy to set up our ratio, our sides which are in the same ratio, when we have highlighted like that. The same must prove that AE, so we look, AE, where's AE? There's AE, and it is opposite the blue. So we must look at the side in this triangle, which is opposite the blue, which is AD. Also, it means that AE, number B, AE, which is AE, opposite this side, and this triangle, AE over, obviously, this side is AD. in this triangle, this angle is opposite this side. In this triangle, this angle is opposite this side. And we've proved that the two are similar. Therefore, AE, which is opposite this angle, over AD, which is opposite this angle, is equals to, obviously, they've talked about AC. AC. So AC, obviously, is opposite that. But since we've started in this triangle to get AE over AD, which is over the side of this triangle, we're going to start in this triangle again, where we're going to have AB, which is AB, over what? We must look at the side in this triangle, which is opposite this angle, which is AC, over AC. AE over AD is equals to AB over AC. Why is that? We know that triangle AEB is similar to triangle ADC. Therefore, we can cross multiply this multiplied by that is AE times AC, which is equals to this multiplied by that, AB times AD, which is there. AE times AC is equals to AB times AD. It is easy when you highlight your equal angles on one triangle to be equal to another angle on the other triangle. So it is easy to set up your ratio if you have highlighted the angles which are the same. You can see. Now, they say to us, we must prove that CB squared is equals to AC times EC. Now with this problem, which is C, this is A, there's our B, we've just proved it. Now we want to prove C. I would love to remove here. Now, for us to prove this, we need, since we have this side and this side, we also have this side there. Oh, so it means that this side and this side, they are in this triangle. That's the first thing when I'm looking at this. They are in this triangle. So this side CB, this side AC, it's in this triangle. Oh, if I can prove that this triangle is similar to this triangle, then I can set up that and prove this. So let's first prove that this triangle is similar to this triangle. Once you have proved that this triangle is similar to this triangle, then we are going to set up our ratio, then prove that. Let's prove it. In triangle BCE and triangle ABC, what do we have? We have that. Now I'm going to remove here so that I don't confuse. I'm going to remove here so that I'm not confusing. I remove also here. confusion. This is just for confusion. Right. Now, this is what we have. In this triangle and in this triangle, this angle is equal to that angle. This angle, which is angle A1, is equals to angle B1. Why? This angle is equals to this angle. You can see this angle is subtended by this line. This angle is also subtended by this line. Therefore, angles subtended by equal lengths. Because this angle is subtended by BC, which is equals to CD. Therefore, this angle is subtended by CD. Therefore, this angle is equals to that angle. Angles, opposite or subtended, opposite, equal length. Now, we can see now that this angle is equals to that angle. Now, this angle is common because this angle, it's an angle for this triangle. It's also an angle for this triangle, this angle. Therefore, angle C2 is equals to angle C2. Reason? Angle C2 is common for both triangles. Now, obviously, this angle is going to be equals to, which is obviously this angle is going to be equals to this angle there. Because we are proving that this triangle is similar to this triangle. Already we got that this angle is equals to this angle in this triangle. We've already got that angle C is common for both triangles. We've also can see that this angle, it means that it is equals to this angle there. A angle BC, A angle BC is equals to angle E3. Third angle of a triangle. Third angle of a triangle. Therefore, triangle BCE is similar to triangle ABC. Reason? Equitriangles, equiangular triangles. Now, since this triangle is similar to this triangle, we can set up our ratio. Now, we must highlight all the angles which are equal. This angle there is equals to this angle there in this triangle. Also, we know that angle C is common. We know. We also know that this angle here, we also know that this angle here is equals to this angle there. Angle C is common. Right. Now, for C, since we have proved that BCE is similar to ABC, since we have proved that this triangle is similar to this triangle, and we have highlighted that this angle is equals to this angle there, and we know that angle C is common, and we know that this angle in this triangle is equals to this angle in this triangle, then we can set up our ratio. Now, for us, obviously we've got CB, which is opposite this angle and this triangle. CB over, obviously, in this triangle, this side is opposite this side. So it means that CB, which is opposite this angle, is equals to, or over EC, which is opposite this angle and this triangle, is equals to, they want us to say AC. Now I can see AC is opposite this angle and BC is opposite this angle. Now it means that AC, which is opposite this angle and this triangle, over BC, which is opposite this angle and this triangle, over BC. Why is that? We know that triangle BCE is similar to triangle ABC. That's the reason why. Now, this multiplied by that, CP is the same as BC. Therefore, CB squared is equals to this multiplied by that is AC dot EC, which is that. So most cases, when they say prove this, you must look at which side are on which triangles. I can see that CB is in this triangle. I can see that AC is in this triangle. I can see that EC is in this triangle. Also, since I have that which is EC in this triangle, and I've got AC which is in this triangle, I need to prove that this triangle is similar to this triangle, as we have done there. Then after we highlight our equal angles, then we can set up our ratio. Then we know that since this is opposite this side and this is opposite this angle there, then we're going to say BC over EC is equals to, since this is opposite that and this is opposite that, is equals to AC over that. Then we cross multiply and prove that there.